Hi, welcome back. In this video, we're going to look at the chain rule from a graphical perspective. So we're given two graphs, graph of F, the pink graph, and the graph of G, the blue one. And we're told that H is the composite function F composed with G, and J is the other composite, G composed with F. In part A, we're asked to find H prime of 1. And in part B, we're asked to find J prime of 1. So let's look at part A. In part A, to find H prime of 1, we're going to need H prime of X. So we need to differentiate H of X. So let's write out what H of X looks like. H is F composed with G, so that means that H of X is the function F of G of X. So we can see F is the outside, G is the inside function. So using the chain rule, H prime of X is the derivative of the outside function evaluated at the inside, so that's F prime of G of X, times the derivative of the inside, G prime of X. All right, so now if we want H prime of 1, that means we're looking for F prime of G of 1 times G prime of 1. So now let's find G of 1 from the graph of G. So looking at G is the blue graph, locating X equals 1. So we're going to plug in whatever we find for G of 1. So it looks like there's the point 1, 3. So G of 1 is 3, so we're going to plug 3 into F prime. And now we need to find G prime of 1. So G prime of 1 is going to be the derivative of G at X equals 1. So we need to multiply F prime of 3 times G prime of 1. Let's first find F prime of 3, then we'll find G prime of 1. So locating X equals 3, and then going up to the graph of F, we want to know what's the derivative at that point. What's the derivative of F at X equals 3? Well, luckily, it's a line segment, and all we need to do is find the slope of that line. So using 2 points on that line segment, so there's 2 points, and we can see the change in X is positive 4, the change in Y is negative 1, and so F prime of 3 is negative 1/4. Let's do the same thing for G prime of 1. So looking at the graph of G and locating where X is equal to 1, going up to the blue graph, that point 1, 3. What's the derivative at that point? Well, it's the slope of that blue line segment, and we can get another point there, and we can see the change in X. Change in X is positive 1, the change in Y is negative 3, so that slope is negative 3 over 1, so G prime of 1 is negative 3. So now we're just multiplying together F prime of 3 times G prime of 1, so it's negative 1/4 times negative 3, and we get positive 3/4 for H prime of 1. All right, so now I want you to do the same thing with J prime of 1. So first write down what J of X looks like. Use the chain rule to differentiate J of X to get J prime of X. Plug in 1 to get an expression for J prime of 1, and then use the graphs to calculate the derivative of J at X equals 1. All right, so I hope you got the correct answer. The correct answer was J prime of 1 doesn't even exist. And let's see why. So if we write down J of X is the composite function G of F of X. So G is now the outside, F is now the inside. So using the chain rule, g prime of x is going to be the derivative of the outside evaluated at the inside times the derivative of the inside. Okay, so now j prime of 1 is g prime of f of 1 times f prime of 1. All right, so now let's look for f of 1. We're looking at the pink graph. F of 1 is 2. And then, so we're going to find g prime of 2, and we're going to multiply that by f prime of 1. So now, looking at the blue graph, we got to find g prime of 2. When we find x equals 2 and then look at the blue graph, we have that point, and it's a sharp corner. That's called a cusp. And notice that it's where two straight line segments come together. So if you were to find the limit, the left-hand limit would be the derivative of the line segment on the left. The right-hand limit would be the derivative of the line segment on the right, and we can tell by looking at them, they don't have the same slope. So g prime of 2 doesn't even exist. Since g prime of 2 doesn't exist, that means j prime of 1 doesn't exist, so I'm not even going to look for f prime of 1. All right, so that's how to use the chain rule on a graphical example, which I think you have on your own. And you'll see a few more videos on the chain rule. So I'll see you all there.